Hello and welcome to the lecture on DLL's PE header, where we are going to look at the export directory structure, which forms a part of a PE header. In order to study the PE header, we are going to use kernel32.dll by opening in a tool called PEBear and look at the PE header. We are also going to open a file called winnt.h, which is an important header file which comes installed with your Visual Studio 2019, and it is found in this location. The kernel32.dll can be found in this location. So on the left of this diagram, I have opened a winnt.header file in Notepad++, and I've searched for a structure called the export directory structure. This export directory structure forms part of a PE header. On the right, you can see that I've used PEBear to open kernel32.dll, and I've clicked on the optional header tab, which shows the export directory structure, which is this one. And then if you wanted to view the raw hex values of the memory location, you can right click on this address here. This is the relative virtual address. If you right click on this, it will open up the memory on the top panel, and then you can examine the raw values, the hex values there, and you will be able to analyze and see that all these values here correspond to this structure on the left here. So we are going to do this later on when we do the practical session. Now I'm just showing you the theoretical background knowledge which you need to know before we go and do the practical on this. Now this is another diagram showing the same two files, but on the right I now click on the Exports tab. As you can see here, Exports tab. So the Exports tab will show you in a human readable form what is on top. And this is easier to understand, and you can actually find the correlation between this and this. So you can see here the first member of the export directory structure is characteristics, and here you can see characteristics, and the value is 0, and you can see here the value is 0. 4 bytes, all zeros. And then the second member is time date stamp, as you can see on the right, time date stamp, and the value is in hex 554D6C15, which corresponds to this. Read in reverse because of little endian in CPU, Intel CPU, we read in reverse order, so you read as 00554D6C. Sorry, it should be here, 554D6C15, which is this. And then the third member is a word major version, and you can see here major version is 0, referring to this word. A word is 2 bytes. And then the next one is a minor version. Here also you can see minor version is 0, which refers to these 2 bytes here. And you can go on down and analyze it this way. On the left is your source code, on the right is your hex view of the PE header. So let's try to understand how the PE loader resolves the function names. When the program wants to run, the PE loader will load the file into memory, and part of the process of loading the file involves trying to resolve the function names. And in this diagram, on the top left hand corner, is the export directory structure, which is taken from here. And then on the bottom right corner here, I've expanded these three members into a easier to understand diagram view. So this one here, address of functions, refers to this diagram here. And this is the function address. So each of these values stored in here are addresses, for example, in hex 2345 and so on. And this is the list of all the functions that are exported by this particular DLL. Another name for this array is export address table, in short EAT. Next one is address of names, is represented here. So all these are name strings. They are addresses to strings, for example, write process memory. So these are all human readable strings, which I've used N0 to represent the strings, N1 and 2 and so on. And one of these could be, say, write process memory, another one could be get proc address, next one could be get module handle, and so on and so forth. So these are the names which are the string names for the functions. And then the next array here, down here, I call the ordinals. Ordinals are just numbers that represent the strings. So the first string may be write process memory having ordinal 0, and then here you might have get proc address having ordinal 1 and so on. So why do we need to have these ordinals? So the ordinals help to map the function address. So for example, if the PE loader wants to find out a particular function name called N3, so the PE loader will go to this names array and then look through each of the member of the array until it finds N3. Once it finds the name N3, N3 could be write process memory, for example, and then you will go down to the ordinals array and look for the corresponding ordinal for N3. So it will find that the ordinal for N3 is 5. So once it finds the ordinal for N3, you can then go to the function address array and look up 5. So 5 will be here, 0, 1, 2, 3, 4, 5. So A5 will be the address for write process memory or N3. So this is how the PE loader resolves function names. It is also important to know what is the meaning of base. Base here means that what is the starting ordinal number for this export directory. Ordinal number need not, although this is just 0, 1, 2, 3, 5, 8, sometimes because you have a base which is non-zero, you have to add it to this. So if your base is say 2, then you have to add 2 to this, and then from here you will get the actual ordinal. If let's say you know the ordinal number and you want to find the actual ordinal here, you have to minus from here. So let's say you have ordinal 10 and you want to locate it in this structure. So you have to take 10 minus your base address, base ordinal, which is 2. So 10 minus 2 is 8. So from there you will go to 8. So you get 8, so you go here and look for 8, and there you have it, 8. 8 points you to this address. So this is how the PE loader resolves function names. So this is how the PE loader resolves function names. In the next video, we'll do a practical walkthrough on this. So I'll see you in the next one. Thank you for watching.